previous lesson, we said before if we had the bases being the same, that we could ignore the bases and look just at the exponents. So to do that, we would have something, in this case, if I can do something I can read, we have 5 to the 2x equals, I can write this as a power of 5. 5 to the third power gives me 125, and I just multiply my exponent from there. So that means that 2x would equal this multiplication, 3x minus 12. So that means I would then make it that 12 equals x as my answer. Same with this one here. I can write both of these as powers of 3. So 3 to the 2x, and then this one would be 3 cubed, and then 3 times 4, which gives you 12. So 2x, in this case, equals 12, which means x equals 6. Now, in this last one here, this is where we have issues, because there is no number I can raise to a power and get 4, raise to another power and get 15. So what I need to do is take what is the inverse operation of doing an exponential, and that is taking a logarithm. So I need to take the log base 4 of both sides. Log base 4. So that means my answer here, when I do that, the 4 and log base 4 cancel each other out. And I'm left with just log base 4 of 15. Now what is log base 4 of 15? Well, honestly, I have no idea. So this is how we do it. In our calculator, we type in log of the big number divided by log of the base, of the little number. And when I type that in, I should get my final answer, which is log 15 divided by log 4. If I type it in right, will give me an answer of 1.95. That is the decimal answer. If they want an exact answer, this would be either one of these would be perfectly fine, good answers. Now, we also need to look at something else called the greatest function in the world. That greatest function is the letter E. It's kind of like pi. It's a number that keeps going on and on forever. It's about 2.71. Now, what we are using E for? Why do we care about E? Well, look, this is what we just did with our last problem. That we had 4 to the x equaled 15. We did the logarithm just like that, and we got that answer. But what if I had e to the x equals 15? Well, in the same idea as the first problem, we would do a logarithm, log base e of both sides. However, the log base e is a special kind of logarithm. It's that important that we don't call it log base e. We actually call it something else. We call it the ln, the log natural, the natural log. So log base e is the same thing as saying the natural log. So I need to take the natural log of both sides. When I do that, I'll be left here with x equals the natural log of 15. And I can just type right in my calculator, natural log of 15 to get a decimal answer. It's about 2.708 as my answer. Alright, so now we know how to do these. Let's see if you can solve these problems. Go ahead, pause the video, and give it a try. Alright, let's see how you did in these first ones here. All these may involve logarithms, so what I need to do is I need to do log base 6 of both sides, log base 6, and log base 6 of both sides. I should end up with 3x equals log base 6 of 19. Okay? Now, to get x by itself, I'll divide both sides by 3. So x equals log base 6 of 19, I should say, sorry, all over 3. And I type that in my calculator. That would be a perfectly good answer. If I want a decimal approximation, I type in log 19 divided by log 6. I get a number which is about 1.6. Divide that by 3, and I should get 0.55 about as my answer. For the next one, same thing. I need to take a log of both sides. In both cases, it'll be log base 5 to both sides. Now leave me with x plus 2, because those will cancel out, and it'll equal whatever log base 5 of 88 is. To get x by itself, I need to subtract 2. So log base 5 of 88, and then subtract 2 from both sides. Type that in your calculator. Log 88 divided by log of 5, and then subtract 2 from that answer, and I should get 0.782. Alright, the last one. we need to do the final step. Alright, in this last one, first thing you need to look at is the fact the exponential is not by itself. We are multiplying by 4 first. So first thing you need to do is divide both sides by 4. That gives me e to the 2x equals 41 divided by 4. I'll just leave it as that fraction, 41 over 4. Now I can take a log of both sides. Well, the base is e, so I need to take a natural log of both sides. When I do that, I should now have just 2x left on the left-hand side, and I'll equal whatever the natural log of 41 over 4 is. Then to get x by itself, I need to divide that by 2. So the natural log of 41 over 4, and then divide by 2. And if I type that into a calculator, natural log of 41 over 4 is about 2.3. So when I divide by 2, I should get 1.16 approximately as my answer. So there you have it. Just make sure you always do the inverse operation, and don't forget about the greatest function in the world, the letter e.